Alright, our next video for section 1.4 is going to be on determining the domain, and you'll be glad to know that this will be significantly shorter than the video that you just watched about functions. Alright, so first remember that the domain is the set of all x values that result in a valid equation. Invalid equations are those that result in a y value that is either undefined or not real. And there are essentially only two problem areas when it comes to figuring out the domain. These are the two different checks that you have to make. If these two situations are not involved in the problem, then there are no restrictions on the domain. It's all real numbers. Okay, so the first one is anything that results in a 0 in the denominator. Okay, because when you divide by 0, that is undefined. So the first thing you need to do is make sure that there are no restrictions that cause a 0 in the denominator. The second is anything that results in an even root of a negative number. Okay, because if you take the square root of a negative number, you guys already know that that's imaginary. So what do we have to do to figure out what the problem areas are? Let's take a look at this example right here. This is a very simple example. We don't have to worry about any square roots or fourth roots or sixth roots or anything like that. That's not part of this problem. But what we do have is x squared is in the denominator, and as we know, you cannot have a 0 in the denominator. Well, that makes this example very simple because x just cannot equal 0. Sometimes you won't be able to tell that easily, but in this particular case, all it is all reals except x cannot equal 0. So the tactic that you're going to use on this problem is to take the denominator and set it not equal to 0 and simplify it. I'll do another example to help square this away. How about this one right here? Okay, again, I'm going to go back a second. Take the denominator, set it not equal to 0, and simplify it. That's all you have to do. So I take the denominator, set it not equal to 0, and then simplify it. So naturally right here, you realize, oh no, I have to factor, and that makes me upset. We've been through this. Shush. It factors to x minus 3, x plus 1. And so now you know that x, remember, we have a not equal to, okay, which means that the domain is everything except negative 1 and positive 3. And there's different ways that you can write it, but what this notation here is telling you, this right here means real numbers as opposed to imaginary numbers. Okay, so what this is saying is all real numbers except x cannot equal negative 1 or positive 3. Anytime you see me on the board talk about real numbers, I write it like that, and so do most math teachers. So all real numbers except x cannot equal negative 1, positive 3. Again, just take the denominator and set it not equal to 0 and simplify. Alright, so let's talk about the second type of problem. Like this one here, y equals the square root of x plus 2. Okay? For these problems, just take the expression under the radical and set it greater than or equal to 0 and simplify. Remember, in the last example, the denominator could be 0. In this example, what's underneath the radical cannot be negative. Doesn't matter if it's 0. This right here cannot be negative, so it has to be greater than or equal to 0. Those are the only two things you really have to look for in determining the domain. So, take what's under the radical, set it greater than or equal to 0, and solve. So the solution for that one is all real numbers greater than or equal to -2. Okay, now I mentioned that you want to look at the denominator and set the denominator not equal to 0. I never mentioned anything about the numerator because the numerator has no effect on the domain of a problem. There are no restrictions in the numerator of a problem unless there's a radical, okay, but you already knew that. So all we're interested in is the denominator in those types of problems. So one last thing before we stop this video. Any other function that doesn't have a radical, doesn't have a denominator, the domain is going to be all reals. Alright, so for example, if I have y equals x squared minus 3x minus, I don't know, 156. Why not? In that particular example, there is no denominator. There is no radical. That means there is no problem. It means that the domain is all real numbers. Okay? So again, look for a denominator, look for a radical. If those two things aren't present, then you're good to go. Bye!